In this section, we're going to take a look at simplifying and using the square roots. Objectives for this section are simplifying expressions with square roots, estimating square roots, approximating square roots, simplifying variable expressions with square roots, use square roots in applications. Let's take a look at this together. So the first thing they look at here, they want you to have the idea of what is the square of a number. Now, the square of a number is simply the result of the same number being repeated by itself, to itself here. That is to say, if I have here the square of a number, the square of a number is simply the number that is repeated to get a particular number. In this case here, the square of a number is going to be the square of n. What number repeated by itself will give me that number. So that in this way here, we can say that the square of 3 is 9. 9 is a perfect number, a perfect square, because it's the square of a whole number. Any number that is the square of a whole number is called a perfect square. Here in this next following down here, you have some examples of perfect squares. 1, 4, 9, 16, 25. All of those are the results of what happens when you multiply a whole number by the same whole number. A perfect square is the square of a whole number. An example here, they give us a negative 8 squared is the result of multiplying a negative 8 by a negative 8. So, notice what they're saying here is that anytime you multiply two negative numbers, the product is always positive, because remember back, we talked about the rules of multiplication. Anytime the signs are the same and you're multiplying, the answer is positive. Okay. Notice here, when the ends are negative, n squared is always positive. So whenever you square something here, you're always going to end up with a positive number. Now square root goes the other way with it. Square root goes another way with it. Okay. A number whose square is m is called the square root of m. So in this case here, the n here is the square root of m. So the square root of 64 is 8. In some cases, you can have more than one square root. So in this case, we have 100. A negative 10 squared is 100. Also, 10 squared is 100. So in this case here, 10 and negative 10 are both square roots of 100. So in this case here, what if we only want the positive square root? Then we refer to that positive square root as also called the principal root here. So here is square root notation. This particular notation here is read the square root of m. Okay. And that symbol is called a radicand, radical sign. Inside, what you take the square root of is called a radicand. Then you show what happens. Take the square root of perfect squares. Square root of 4 is 2. Square root of 16 is 4. Now they ask us here to find the square roots. Okay, so a way of asking this here is, what number, when repeated, will give me 25? That can multiply by itself will give me 25. 5. What number, when multiplied by itself, will give me 121? 11. Okay. This one asks, what number here, when multiplied by itself, will give me 36? 6. What number, when multiplied by itself, will give me 169? 13. 13 times 13 is 169. So in this case here, we have a negative on the outside of it. What we really have here is that it's the same thing as negative 1 times the square root of 9. The square root of 9 is 3, so my result is going to be a negative 3. For the other one here, what I have is 144. What I really have is a negative 1 times the square root of 144. Square root of 144 is 12. So my answer is going to be a negative 12. Now, let's take a look at this special case here. You've seen you can take this when the negative's on the outside, it's no problem. But when you have a negative number on the inside, then you're going to have a problem. What number, when repeated by itself, will give me a negative 25? What number, when repeated by itself, will give me a negative 25? Keep in mind, if it's a square root, then it's the same number, and that means the signs are going to be the same. And if the signs are the same, then the answer is positive. But in this case here, it looks like the product is going to be a negative number, so the signs are not the same. There isn't a number, a real number that'll take this case. So if they ask us to find the square root of a negative number, we simply write not a real number. So some examples of that here. So for 169, it's not a real number. But for B, we have a negative on the outside. So you can find that one to be a negative 11. And I'll stop right there.